Okay, so I will just start today's class session, right? Have few things to brief you, have few things to show you uh, before I go to the notes and discuss about certain chapters, right? As I have informed you before, that beginning this week we are going to do uh, on the topic of data analysis. So today I'll give you some brief introduction about what data analysis is, right? And then we look into what we have. Okay. Um, First of all, basically, I have updated your portal with all the materials. Okay. So before this, maybe perhaps before your mid-sem break, I have uploaded until research design. So basically, I have uploaded some of the slides using the new version given by the coordinator, chapter 7, 8, and 9. And also based on what we have discussed, okay, based on what we have discussed on Thursday, that some of the chapters in chapter 9, right, will be presented through video recording. We consider it as an asynchronous learning, right, and based on the information that I get from the management is that for you to do some self-learning through video recording, right? For a class of one and 1.5 hours, it is not necessary for me to record uh, the class for an hour, right? So instead, they inform that, well, as long as students are being exposed to a 12 minutes video, it is basically equivalent to an hours of study. Right, so I managed to get some of the short videos available in online, through online. Okay, so I have given you the link, right? It is basically on my Padlet. Okay, so you can have a look. Using this link, you will be brought to my Padlet, and then you can have a look on all this video, right? Talking about the things that we have discussed on population and sample. Right, then like I told before, okay, we have sampling design and then we have sampling technique. So basically these two videos are about the sampling technique, the probability sampling and the non-probability sampling. And each of these video, they have a detailed elaboration or explanation about each of these sampling technique, right? So you can have a look in this video, and maybe at the end of the semester when we have time, we can basically consider looking at this back. If you need my explanation or further discussion, right, you can approach me to talk about what is all these techniques. Okay. Then I have given you the materials, right, with regards to data analysis. So you have data analysis 1 and data analysis 2. These are all the materials that I hope, right, you can spend time watching, right, because along the way, okay, I will be using information about this. So if you can watch these videos uh, ahead of time, in advance, that will be very, very much helpful for you to understand on the what we call it, on the data analysis section, right? When it comes to topics, when it comes to certain data analysis techniques that I am basically introducing or I'm basically explaining, right? Having these videos will basically help you. So the first part of this section is introduction to univariate. This video we are going to look at it later on when I start giving some explanation or lectures with regards to this analysis. Then these are the breakdown of what each analysis is. Okay, right? And in order for us to proceed with this, what we call it, data analysis chapter, I gave two instructions. Okay, first is to download Jamovi software, right? Later, I will show you what are the beauty and what are the differences between Jamovi and SPSS. Okay, basically, SPSS, you need to either find a pirated version or a cracked version in order to use it, right? Or you need to use the one provided by within the university Wi-Fi network. So, as a supplement or as an alternative to SPSS, I basically recommend the students to use Jamovi. Later, I will show you some example. Okay, basically they have no differences, and instead, it is felt like the Jamovi is much more user friendly. So for those of you who are interested or will be planning to do or applying this research method techniques in your subsequent semesters like seminar and logistics, etc., right? This software might be useful. Okay. The second part is basically I provided you the link to video tutorial. Okay, let's look at the first part. Okay, it is to download and install Jamovi. So when you click inside here, it will give you this link. You click on this link, it will bring you to this site. Okay. So there are two versions for Windows. Basically, 1.6.23 is more stable, okay, whereas 1.8.2 gives you the latest feature. So depending on your capacity of a computer, you can try to install both. If you think that you download 1.8.2, it doesn't really run smoothly, then I would have encouraged you to go back to 1.6.23. Right, you can have this installed, and it is somewhere around 200 MB for you to download this software as compared to SPSS, which is much more larger. Right, then the next thing, once you have done with this, okay, I also provided you a reference point. Okay, if you click on this link, it will bring you to a YouTube channel. Okay, a channel by Data Lab CC, right? So this channel gives you 56 tutorial video with regards to Jamovi. Okay, how to download it, how to install it, how you can manage your file, manage your data. So like I said, okay, I cannot teach you everything within these few classes. So what I managed to get and what I managed to do is I managed to get all these video tutorials in case you encounter any problems or any issues with the software. You can have a look on this YouTube video. Consider this as your video guide or tutorial guide. Okay, so let's have an introduction video on what actually Jamovi is.
Welcome to Jamovi. Jamovi is an application for analyzing data and helping you make sense of the information around you. It's also a compelling alternative to expensive proprietary programs like SPSS and SAS and Stata. Instead, Jamovi is based on the open source programming language R, which is designed for working with data. And what that means is that Jamovi is free, it's open, and it's extraordinarily friendly. In fact, once you start using Jamovi, you'll simply be embarrassed that you didn't start using it sooner. Now, I want to mention one thing about this course. This is a tools course. I'm teaching you how to use software. It works best if you already know a little about data because I'm not going to be discussing the principles at great length. On the other hand, it's easier to learn data when you have a good tool like Jamovi. So really, either way works fine. Just get started and see what you can do. Go to jamovi.org and download the program, and then go to datalab.cc/tools/Jamovi to download all the course files so you can follow along with what we're doing and start working in your own data too. And with that, let's go. The first thing you need to do to work with Jamovi is to get it installed on your computer. It's a desktop application, so you'll need to have either Windows, Mac, or Linux, and you install it and run it locally. Go to jamovi.org and then simply click on this link, download. Now the beautiful thing is it's free and it's open source. Click the system that you need, Windows, Mac OS, or Linux. Download the file, double click on it, and you'll be ready to start working in Jamovi in just a few seconds. The first
Okay, so the video was basically presented in 2018 for installing. Now that you can have a look on this website, click on download. These are the versions that you can pick. Okay, let's see what it talks about installing Jamovi.
First thing you need to do to work with Jamovi is to get it installed on Windows. Double click on it, just a few seconds. When you open Jamovi, you're going to see the single unified window that contains all of the operations and output that you need to do to analyze your data. On the left, you see the rows and the columns that look like a spreadsheet. This is your data window. Now, right now there's no data in it, but there are three default variable titles that come up on the top. We have the variable A and B and C. And remember, a column is the same thing as a variable, and a row is the same thing as a case or observation. Off to the right is the output window where you'll see the results of your analyses. Across the top of this menu bar are 6 different sets of commands. The first one is exploration. Now, at the moment, this one has just a single command in it, descriptive, but that's enormously useful. And when you click on that, what Jamovi does is it brings up the dialog for that command, and you'll see that it looks a lot like SPSS. That's intentional. Jamovi's not built on SPSS, it's built on R, but it's designed to be comfortable, familiar for SPSS users. And you simply select the variables, put them in this list over here, and then you start filling in this template. You, of course, can also choose various plots, like histograms and box plots, and statistics. And you can close it by clicking right here. Now, the other menu options include 3 most common versions of the t-test, several versions of the analysis of variance, including both parametric and non-parametric versions. Under regression is correlation and regression, including ordinal regression. Frequencies has the binomial test, the chi-square test, and even log linear regression. And then factor has the reliability analysis. So if you're looking for Chromebox alpha, that'll be right here, as well as principal components analysis and both exploratory and confirmatory factor analysis. One of the neat things about Jamovi is because it's built on R, it's extensible. If you come over here to this modules and click on that and click Jamovi library, these are additional collections of code which give extra functionality to Jamovi. One of the most important is this one right here, RJ. This is the ability to run any R code inside Jamovi. That makes it infinitely extensible, as well as a number of other ones that are more restricted. For instance, the R data sets could be a good one. Next to the Analysis tab is the Data tab, which allows you to both bring data into Jamovi and to set it up. You can paste data, you can cut, you can copy. If I click Setup, that allows you to change the variable names and add descriptions, change the variable type. So is it a continuous or quantitative variable, ordinal, nominal, or categorical, or an ID variable? And then within several of these, you can specify whether it's integer, decimal, or text. Over here under levels, you can add labels for the different values. If you use SPSS, you know how to use value labels. That's where you set that up. You can also compute new variables. I'll close this first. You can compute new variables. Say, for instance, you need to average several different variables. You would do that right here. Transforming variables is if, for instance, you want to add 1 to 5 coded as low, 6 through 7 coded as medium, and 8 and up coded as high. That's easiest to do right here, where you can think of it as several if this, then that, else do this. You can add and delete different kinds of variables. You can filter the cases according to multiple criteria, and you can add or delete rows to your data. Finally, I want to show you 2 additional things. At the far left here is 3 lines That gives us the basic commands of Jamovi to open a new file, to save, export. And then at the far right, these three dots are where we have our preferences or options. So things like the number format. The plot theme has to do with things like what's on the axis and what the background looks like. Separate from that is the color palette, and you have a lot of different options here. How you handle missing data, the option to automatically update Jamovi, a built-in screen capture tool. So if you want to take a photo of your Jamovi screen, this is one way to do it. Yeah? And then finally, a developer mode. But I want to draw special attention to this option right here, which is syntax mode. When you click on that, notice how the output has changed. This is an R command using the JMV package available in R, which duplicates the default functionality of Jamovi. And this is a way that you can copy and paste the output into another program. And so it's possible to use Jamovi to create R code, and it's possible to include R code into Jamovi. So there's a wonderful interchange between the two. Anyhow, this is the default layout of Jamovi, and I'm going to show you how each of these options and how each of these functions work in the separate videos. But now that you're oriented, we can get started on each of those.
Okay, so I give you some introductory video about what Jamovi is. Okay, for you to really try on, let me have an introduction to Jamovi. Okay, so this is how Jamovi should look like. Okay, exactly like the what we call it, the video. But the beauty of Jamovi is it comes up with a few basic data set for you to use. So I will be demonstrating how does SPSS differs from Jamovi, right? So this is SPSS, this is Jamovi. So perhaps I can make some comparison on side by side. But what I'm going to show you is that I'm basically be using the same data set. Okay. The first thing difference between SPSS and Jamovi is that for you to learn Jamovi, Jamovi provided you a simple data set. Okay, so you can click on the three line here, then you can click on open, then you can have data library, right? So they give you 4 examples of data that you can basically use to test run or to play around with the software. Now let's say I'm using these sets of data. Okay, so you can see that these are the data, these are the actual data that you have collected. So according to this data, there are basically, let's see, 500 responses. That means to say 500 data was collected from the sample, and there are 1, 2, 3, 4, 5 variables. Okay, I will just do a quick demonstration on how actually Jamovi works. Okay, by using some of the function. Say for example, this is a neuroticism data. Okay, so there are 500 person responding with each of them giving different kind of score. Okay, Jamovi can help you to express at a very minimal level. For example, in this case, you want to look on what is the highest score that was given by one of the 500 respondents and what is the lowest score. Okay, or perhaps you are more interested to say what is the actual mean or average score for neuroticism among the 500 people. So this is how Jamovi works. Okay, when you start to understand how to use the software, right, you can just click, for example, I want to explore, right? I want to explore what is the mean, mode, or median of this variable. I just can click on exploration, then I click on descriptive. Okay, so what happened here now is that the software will ask you to input the things that you would like to look. So I said I want to look at neuroticism. I have 500 people responding me on neuroticism. So I drag it inside here, and automatically the software will generate the data for me. Okay, So I have sample 500. There is no missing data, right? The mean of 500 response is 2.83. The median is 2.8. Standard deviation 0.453. The minimum score that people give to me on neuroticism is 1.65. The maximum score is 4.38. So this is how Jamovi works. As long as you have data inside put in, you can use the analysis function, then basically you will get your results. What else can the software do? You can click down on the drop-down menu. You can ask for more information. For example, you want to know about the skewness and kurtosis, you just click and then the software will give you the results. If you don't want, just remove it, right? If you want to know about the range, okay, you can see the range basically 4.38 minus 1.65 is 2.73, right? So this is the beauty of what we call it Jamovi, because it gives you a quick click, then you can get whatever result. Okay, say for example now, apart from having all these statistics, let's say you want to have a plot like histogram or like pie chart, etc. You can click on plots, you click on histogram, the software will generate for you the histogram. Okay, if you need a box plot, you click a box plot, it will show you the box plot and it will show you what is actually the outliers. Okay, so this is how actually Jamovi works. Okay, now we look at these results. Okay, right? You have these results. Using the same data, I'm going to show you SPSS. Okay, a bit complicated because there are many clicks that you need to do. Okay, you can go to analyze. There are so many functions as compared to Jamovi. Because you are just undergraduate students, you don't need to use such a complex software. So basically, they have all the menus here. But in SPSS, you need to click on analyze. You need to know what function that you want to use. For example, now you say you want to do descriptive statistics, right? There are so many statistics that you want. It don't allow you one shot, right? For example, you want QQ plot. You need to do QQ plot. You need to click it separately. Whereas in Jamovi, you just need to tick here. You've got the QQ plot. Okay, you got this. Right? Go back to SPSS. So you analyze, descriptive. You go to explore. Okay, because we're using explore. Then you click on neuroticism. Then you have to click again to select what are the statistics that you want. Click again, look at the plot. Click again to look at the options. Right? Then you click OK. Okay, this is the result of SPSS. Okay, and this is the results of Jamovi. So you got the mean score of 2.83. SPSS give you a mean score of 2.82645, which is also 2.83, right? Then you can have your median of 2.80. SPSS give you a median of 2.79604. So it's the same. Standard deviation 0.453. Okay, standard deviation 0.4526, also 0.453. Minimum 1.65, maximum 4.38. Minimum 1.646, which is 1.65. Maximum 4.375, which is also 4.38. So Jamovi give you 2 decimal point, whereas SPSS give you 3 decimal point. And then you have skewness and kurtosis. I can basically take this. I said I want skewness, kurtosis. I want interquartile range, everything. So I can also obtain the same results, right? Standard kurtosis 0.175, 0.273, Okay, minimum, maximum, the range. And then you got what? 95% confidence interval. Okay, I can request from here, right? 95% confidence interval, 2.79, 2.87, which is the same. So there seems to be have no reason on why you need to use a more complex software and you need to buy a license for it, right? So why don't you can just use Jamovi? It's actually the same. The only differences will be the way the result is being presented. And if you see here, okay, you got the box plot, but you do not have a histogram. Now, how can I ask SPSS to give me a histogram? Perhaps I need to do it one more time and see if I can request for a histogram here. Okay, I can click histogram here. So many clicks, so many steps. Then only it will give me a histogram. Okay, whereas in Jamovi, only with this function, okay, I can ask for many things. So far, okay. Am I too fast in explaining the software? Boleh ah? Okay. Which one do you think is much more easier and much more simple and friendly? For me, I think it's Jamovi. What do you think?
Yes, the movie.
The movie, then another issue is that SPSS sometimes depends on your quality of your laptop lah. Right? There will be problem installing lah, this lah, that. But Jamovi is rather straightforward. Okay, so I don't think you have many problems installing Jamovi. But I don't know. Okay, for me, I want things to be easy for you. I don't want things to be a little bit problematic for you. Some will say, "Alah, we don't have SPSS lah. We need to buy lah. We need to download pirated version lah, etc., etc." Other lecturers, okay, during the meeting with all the lecturers teaching research method, I have highlighted this, okay, as part of it. But some of the lecturers, they suggest that they wanted to use SPSS because of they are concerned that students don't know how to read the output. Okay, but since this semester I consider that there is no final exam and you will not be tested in any sense, right, about how to read. Okay, so I still choose to use Jamovi. So maybe you have other friends that are using SPSS or other lecturers in other class are using SPSS. I hope that you don't, you just listen to what they say, right? You don't want to create conflict because I am the one who decide to teach you Jamovi because I think it is easier for me to manage and easier for you to learn. And you have all the resources that I have given to you. Okay. Right, so kalau class lain, other classes, they still say, we learn SPSS, let them be. Because I have already shown you that the result is basically the same. Okay? What will be the differences is that maybe many of you would have considered memorizing, or if I see table like this, I know this is descriptive. If I see table like that, this is a table on analysis or whatsoever. But you need to learn, especially when you come to your chapter 4, right? When you start reporting, I hope, let's say, for example, okay, you can be more creative. Okay, I don't encourage you to be like, how to say, okay, like this lah. Okay, maybe in class I teach you 1 plus 1 equals to 2. Okay, but I don't want you to always memorize the things that I've taught you. Okay, that means to say I teach you 1 to 1, 1 plus 1 equals to 2, and then you just memorize it. Dr. Francis taught me 1 plus 1 equals to 2. No. Okay. I hope that in the class, I'm teaching you that, okay, this is 1 plus 1 equals to 2. But at any point of the time, you can consider an alternative mathematical equation as long as you know that this plus this equals to 2. So what I'm trying to say here that even though I teach you 1 plus 1 is 2, right? You can always come and tell me saying that, sir, 0.3 plus 1.7 is also equals to 2. I know most of you will come and tell me, say, sir, you teach us 1 plus 1 is 2. But now I know 0.3 and 1.7 equals to 2. Can I use it? I would tell you that yes, you can use it because this is what I intend to guide you. So what I'm trying to tell you here is like this. Okay. Let's say this data set is similar to what you are doing in your group assignments in your research project. Okay, you have plenty of variable. Here we do not see, we do not know which one is IV, which one is BV. So consider that once you get your data, you also key in something like this. And then the first section of your assignments, okay, let's go to your guideline. Oh, yeah, and one thing I would like to remind you is that, okay, your assignments, okay, for deadline assignments need to submit on the 24th of June. Okay, this was given to me. Okay, let's say, for example, in chapter 4, the first part, you are asked to do a descriptive analysis. Okay, so now, okay, I show you a descriptive analysis of what? Neuroticism, right? Okay, okay, okay. So I show you neuroticism. Then the second one, you do openness, right? This is for openness. Okay, now, sometimes when I teach you, so you do one by one. Okay, let me show you. Do one by one. So first one, you run neuroticism. Okay, here you run neuroticism. So what you do? You copy, and then you start Microsoft Word. And then you put 4.1. Okay, I put it bigger. 4.1. Descriptive analysis for neuroticism. Then you put here. Okay. Then the second variable. Okay, extraversion. Okay. Right? This is normally how we do it, right? Betul tak? Because you want to play safe. So you report one by one, one by one. And but I want you to improvise. I don't want you to really do something like this. Because since all of these are descriptive analysis, why don't you consider something like this? Just put one section called 4.1 descriptive analysis for, let's say, all variable. Put in this, put in this, put in this, put in this. Isn't this better? Right. Okay, let's see. SPSS, can SPSS give her something like this? Let's see. Hmm. See? Okay. I don't teach you Jamovi, I teach you SPSS. I'll tell you, you will give me this. You will give me this because this is what generated by SPSS. So how many page? Satu, dua. 2 pages. You copy and template the whole thing. You wasted 2 pages. But then in Jamovi, half a page. Did you see the differences? Can you see? So
Yes, Doctor.
you must understand that sometimes you can, based on your creativity, okay, based on your creativity, you redesign the reporting table. I'm fine with that. You jangan copy sebiji macam ni. Dua muka surat for nothing. When everything can be simplified into this kind of thing. Okay, so this is why at least Jamovi make things easy for you lah. If let's say I teach you SPSS, I'll tell you, many of you will give me this table. Then suddenly your assignment become 100 over pages lah. Orang terkejut because PhD pun 200. PhD students sometimes do around 250. But my degree student already 150 pages. Are they doing a thesis? I don't know. But when we look at it, then we know they are wasting your page, wasting size, everything because of this. Okay? So this is what I mean. Okay, try to simplify table. Okay, give me a second. I'm replying a message from the management. Okay, so this is one of the things that I would like to inform you in advance. right? Maybe you look at the sample that was done by your senior also, they give me something like this. No need, just combine everything that you can combine, you do it in a single table, right? Okay, so along the way, I will be showing you things like this. Okay, when we discuss each and every techniques that you'll be using for your SPS, at least I'm telling you that what I'm basically teaching for you as an undergraduate student is basically maybe around 10 to 12% of all the statistical data analysis that one has to learn. But since you are a degree student as an entry level, I will teach you the very basic one. Even for me myself, I think I have not learned even 50% of all the statistical technique available in the world. Okay, I'm also learning, I'm still learning, but at least for you to be able to do a simple reporting, okay, a simple reporting, a simple analysis, like scientific analysis, okay, I will be guiding you along the way. So this is how things are going to work in the subsequent week. I will show you in SPSS, I will show you in Jamovi, right, with sample data. Okay, so this sample data, maybe I will upload to your online learning so that you can use, okay, right, to show you. So um, in case if you have any question about this, you can always ask me, right? Okay, now I would like to move into the very first fundamental principles of data analysis. Okay, okay, okay. So to start with data analysis, I will have to explain to you what are the basic things that you will need to learn and you will need to understand. Okay, because you see, when I give you the assignment, you see, oh, so many variable. They are moderator, they are mediator, right? They are IV, they are DV, independent variable, mediator, moderator. But okay, it all goes back to some very standard knowledge. Okay, which is like I have shown you inside your what we call it, your online learning, each of this chapter. There are three components of data analysis that you can do. The first one is called univariate data analysis. The second one is called the bivariate data analysis. And finally, the last one is called a multivariate data analysis. So what is actually all these things? Okay, I would like to start off with this first. Okay, at least at the very minimal level, when you have a data, okay, when you have a data, tak kira lah, you have one variable ke, two variable ke, as long as you have data talking about variable, tak kira lah variable to variable, like what we call it, like satisfaction ke, commitment. We don't go that detail about those things yet. We just go about a very basic data. Okay, we walk out from our room, we find 10%, and within that 10%, there are male and female. This is very basic, right or not? If you go out and meet a person or meet a group of person, the first thing you are able to see is what? Definitely the person either is male or female, right? Right? Or are you going to meet someone like Sajat? Can you easily meet Sajat around the way?
No, sir.
No, tak ada. Ataupun maybe in your area, simply, I go out, sir. Not only male and female. In my area, I got also the half one. Don't know male or don't know female. Got don't have. Okay. So let's see. We just talk about gender. You walk out and see a group of person. Definitely you will see either male or female. Right? So at least when you want to analyze a pattern, the basic thing you need to know is when it's come to quantitative counting, is you must be able to describe. They don't talk about other things, just talk about gender, male or female, you must be able to describe. And this is the thing that you do. Okay, in the group that I have, 20% are male, 40%, no, cannot. 20% are male and 80% are female. Nothing else than that. Unless you want to say, sir, in the group that I meet, 20% are male, 70% are female, and 10% uncategorized. Boleh juga if you manage to found that lah. And those who in KL, you go to Pudu or you go to Jalan Tugu Abdul Rahman, right? You look at them as a man, but they wear like a woman, so you say uncategorized. Boleh juga. Okay? So at least at a very minimal level, you must be able to describe, and therefore we start off analysis by talking about descriptive statistic. That means to say to describe a pattern that is observed in your data. So what can we learn about descriptive analysis? Okay, this slide I will improvise and then I will give you, because there are so many information that is not required, because this slide is a master student slides. Okay, so descriptive analysis is basically the transformation of raw data in a way that describe the basic characteristics such as central tendency, distribution, and variability. Okay, so how you describe the analysis or how you describe your data needs to be rely on how you actually measure them. And when we talk about how do we actually measure them, right? The variable that we are looking at, we go back to what we have learned in chapter 6, right? Where we talk about scaling. So this is the thing that you need to know. Okay? If you measured a variable using a nominal or ordinal scale, the descriptive analysis that you can do is only a frequency table. What do you mean by that? Okay. Remember when we talk about nominal and ordinal? Nominal meaning to say that you can categorize something into groups. Okay. So for example, you categorize gender into male and female. Right? Either you represent it with 1 male, 2 female, or you just simply say male or female. The kind of descriptive analysis that you can do is a frequency table. Meaning to say you can describe how many male you have, how many female you have. Okay. Ordinal scale also the same. Okay. SPM, STPM, diploma, and degree. 4 categories. Each categories they are being ranking with SPM the lowest and degree the highest. What you can do with this kind of data? You cannot describe the mean. You cannot describe, you maybe in certain way you can describe the mode, but you cannot describe the mean, you cannot describe the median. So what you can do? Frequency table, you just can explain how many people that you meet has SPM, how many that you have met has diploma and degree, etc., etc. Okay, so the first level of statistics for nominal and ordinal scale is always frequency table. Then there are variable like neuroticism that we explained just now, like satisfaction that we have been talking to, like commitment that we have been giving as example in the previous classes. Those variable that was measured on an interval or ratio scale. Okay, the statistics that you can do is called the inferential statistics, or in another way we call it measures of central tendency and distribution, in which you can find means, standard deviation or median. You can find average of them, right? So you have learned in your statistics class about central tendency, mean, mode, median, measures of dispersion, okay, range, quartile, kurtosis, and skewness. These are the things that you have learned. So depending on how you measure a variable, right, you have different kinds of statistics that you can cater to describe. Okay, so some of you might have asked me, sir, we learned about age. So if I were to put age in categories, like for example, category 1, 20 to 24, category 2, 25 to 29, category 3, 30 to 34, then what you can do is only frequency table to explain how many person falls in certain groups. But the same variable called age, if you were just using a blank, a blank space and ask the respondent to fill in their actual age. So in this sense, we call it that you are using a ratio scale. Now, you can do inferential statistics where you can find the mean of age for the group of people that you have interviewed. You can find the standard deviation of the age group. Okay, so these are the fundamental things about descriptive statistics that you need to understand at the very minimum, because later on in your assignments, group assignments analysis, the first thing you need to tell is the demographic background, which is the descriptive analysis. Of course lah, okay, we believe that you need to tell who are the people you have interviewed, what are they comprises of, what is the highest qualification, whether they are single, married, or whatsoever. But sometimes descriptive analysis also can be used to explain the distribution of all the variables that you have in the model, just like what we do here just now. So you need to tell people that for my variable neuroticism, the mean is like this, so people will know. Because, for example, right, if we measure sensitive item, like for example, okay, I want to know about employee performance and I ask the employee about their level of commitment on a scale of 1 to 7. Remember, I asked the employee to evaluate themselves. And then suddenly the mean score that I get for, let's say, 300% that I have interviewed is 6.2 out of 7. What does that mean? That means to say the group of 300 person that I interview tends to rate them very good. Is this a good situation or is this a bad situation? Very subjective. Because if I were to ask you, you will also agree, alah, sir, if you ask us to rate ourselves, definitely lah, we will rate ourselves very good. Where got people so stupid, go and rate themselves very bad. So what happened if this kind of situation happens? The reliability, the trustability of your data is not convincing. Because the first thing you know, without even really detailing down, you know that these people are cheating. They are not as good as what they say. But then you still ask them to evaluate themselves. What happened? People will say your finding is not reliable. We cannot trust what you have found. Why? Because the person who answer your question also are not sincere. They are also cheating. So when garbage in, you produce garbage out. So this is the philosophy of quantitative data analysis. Whatever that comes in for you to process the data, to analyze, must be good and reliable. Not to say, janji ada data cukup, tak. Same goes like your assignments, right? After this, you go and simply distribute. You can get responses, I will tell you. But then, is those responses really valid, really reliable? Are they really answering? Just like the example that I've told you, you want to study about CEO, but the CEO is asking the secretary to respond on behalf. Can we trust that data? No. So when you cannot trust the data, how can you use the data to analyze and then make a report about it? Right? So this is one example that I am trying to say. Okay. Right. So the first thing about basic descriptive analysis is that you need to understand. You have nominal, ordinal scale, you need to do frequency table. You cannot do mean or standard deviation. Let's say, for example, you have a nominal scale of gender, 1 male, 2 female. Okay. When you analyze the data, you say you want to find mean. How to find mean? 1 and 2. You find the mean is 1.5. So what does 1.5 mean? Not either male, either female. Macam saja, 1.5. Tak boleh kan? So there are some things. Like for example, you have SPM, STPM, diploma and master or degree. So 1, 2, 3, 4. And then you want to find the mean, which is 2. Cannot. You cannot do that. Right? But on a interval scale like 1 to 7, 1 strongly disagree, 7 strongly agree, you got a mean of 3.5. That means to say they are sitting in the middle. They are not neutral, but they neither agree or disagree. That's it. Okay. So in order to describe your data, you can do tabulation. You can table it out. Okay. You can table it out in such a way, simple tabulation, cross tabulation, etc., etc. So these are the things that we are going to learn along the way, using the hands-on statistics. Okay. The next thing I would like to share with you about data analysis that you need to know. Right after you have understand what basic descriptive statistics is, the next thing you need to learn about data analysis is called the type of analysis. Okay. Imagine that this is a simple model. Okay, this is a simple model where the first box is your independent variable and the last box is your dependent variable. And you have learned from your research method class, I taught you earlier that whatever sits in between is called the mediator or intervening variable. Okay. So meaning to say that in this framework, you got three variables. Three variables. Okay. For each three variable, you can collect data for each of them. Just like what you have here. Okay. Neuroticism, openness, agreement. So here got 5 variables. For each of the variable, you can do an analysis. Say for example, neuroticism, we have 500 data. The average mean is 2.83. So when you do a descriptive analysis for each of the variable independently, it is called a univariate analysis. Unisex, satu sex. So own person. Okay. Then we move on to the second one. Okay. We also know that like your research objective and research question. Okay. You have independent variable, you have dependent variable. And then you want to examine the relationship between independent and dependent variable. You want to know how much does the independent variable influence the dependent variable. You want to know whether the relationship between IV and DV is positive or negative. Okay? When you do that kind of analysis to explore the association of two variables, it is called a bivariate analysis, represented in a box of red. It can be here or it can be either here. Melibatkan dua, only two variable involved. Okay. Any analysis that goes beyond two variables, okay, 3, 4, 5, 6, 7 is called multivariate analysis. So in this case, some of you would have a model saying that, sir, I think my model got IV and DV only. I know because I give you the assignment. But the issue here is you are also doing a multivariate analysis because remember I told you bivariate only involve two variables. You might have a model that have IV and DV, but remember that your IV is 5 independent variable. You have 5 independent variable testing against one outcome variable, dependent variable. You are doing multivariate analysis because the number of variable that you have is more than 2. So this is the introductory. Now, I would like to show you a video that basically explains in detail what actually univariate, bivariate, and multivariate analysis is. So you can have a look on the video, right? After that, we will continue to discuss some little bit more before I let you go, because I plan to start discussing in depth about univariate analysis on Thursday. Okay.
Okay, so in the quantitative data analysis, one of the most important factor is to understand the level of your analysis. This is determined by the number of variables that you have in your research. And depending on that, the level of analysis is divided into 3 different analysis techniques: univariate analysis, bivariate analysis, and a multivariate analysis. Let's go through each of these one by one with examples. Univariate analysis is the most basic form of a statistical data analysis technique. So when the data contains only one variable and doesn't deal with a cause or effect relationship then a univariate analysis technique is used. For instance, in a survey of a classroom, the researcher may be looking to count the number of boys and girls. So in this instance, the data would simply reflect the number, which is only a single variable, and the quantity of the boys and girls. So the key objective of univariate analysis is to simply describe the data to find patterns within the data. And that you can do by simply using like mean, median, mode, dispersion, variance. The ways univariate analysis is conducted could be most basic form of descriptive analysis techniques like frequency distribution tables, frequency polygons, histograms, using pie charts or bar charts, etc. Okay, so bivariate analysis is slightly more analytic than univariate analysis. When the dataset contains 2 variables and the researchers aim to undertake comparison between the 2 datasets, then bivariate analysis is the right type of analysis to undertake. For example, in a survey of a classroom, the researcher may be looking to analyze the ratio of students who scored above 85% corresponding to their genders. So in this case, there are 2 variables: gender, that is male or female, which is one independent variable, and the result, which is the dependent variable. So a bivariate analysis will measure the correlation between the 2 variables. To undertake bivariate analysis, there are popular statistical techniques like correlation coefficients, regression analysis, and regression analysis could also be like linear regression, simple regression, and there are a whole heap of different other regression pattern or style that could be used to undertake a bivariate analysis. And lastly, the multivariate analysis, which is the most complex form of statistical analysis and used only when there are more than 2 variables in the dataset. So here's an example. A doctor has collected data on cholesterol, blood pressure, and weight. She also collected data on the eating habits of the subjects. For example, how many ounces of red meat, fish, dairy products, and chocolates consumed per week. Now, she wants to investigate the relationship between the three measures of health and eating habits. So in this instance, a multivariate analysis would be required to understand the relationship of each variables with each other. As you can see, there are multiple variables involved in this research question. So commonly used multivariate analysis techniques include factor analysis, cluster analysis, variance analysis, multidimensional scaling, redundancy analysis, and a whole heap of other statistical techniques. So I hope you have understood the selection of the quantitative data analysis is dependent on a range of different factors, and the number of variables is only one of them. So once you know how many variables have you got in your research question or the study in consideration, then you'll be able to select whether you want to go for a univariate, bivariate, or a multivariate analysis.
Okay, all right. So if you still cannot capture, no worry, we have the class being recorded. You can continue to watch on this video. Right, then the next thing I would like to inform is that after I have moved into teaching you what are the univariate, what are the multivariate data analysis, right? I hope also you pay attention to the second section of the video, right? There are 4 tests that basically that I will be teaching you, okay? As a beginner for analyzing your data, these are the 4 basic analysis, which is also appears on top of your movie. T-test, ANOVA, regression. Exploration is descriptive lah. Frequency is also descriptive. So see, I have a video on T-test, ANOVA, correlation, and regression. But these videos, they are not the kind of video that teach you how to click. No, these videos are mathematical equation videos that tells you how those number is being generated and derived. So even though you learn here, you just click, you got the results. Okay, I also hope that you will be able to learn and understand the mechanism behind. When I talk about t-test, some of you might confuse, doctor, what is actually a t-test? Okay, how do you say when you compare mean of 2 samples, what actually does that mean? So this video helps you to understand the meaning behind all the tests. Okay, so I hope you pay time to continue, spend some time to watch these videos. Okay, tak ada final exam, no worry, but at least you learn. Okay, I want you to learn, not to pass exam, not to get A from me. Okay, all right. So I think that's all for today's class lah. Okay, I think banyak benda dah bagi dekat, and many of you start confusing. Okay, a lot of details, so you can continue to revise all the class videos, all the things that I have explained to you. We will start slowly on univariate data analysis on Thursday. What are the tests involved? What is actually univariate analysis? How can we extract information from data, etc. Okay, so that's all for today's class. Thank you very much. If any question, you can ask. And then there is a group that requests to have consultation after the class. Please stay on. Right? Thank you.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Ya, dokter.